Hi, Femog. Welcome to this session. We're going to talk about the data science platform of the future. And I'm going to specifically talk about a lot of cool technologies like vSphere, Kubernetes, GPUs, Bitfusion, and make it one big Nerdfest. So my name is Johan van Amersfoort. I'm a big nerd, and I work as a technologist for ITQ consultancy based in the Benelux, where I'm partly responsible for the vision and strategy of our end user computing and artificial intelligence business units. Now, in today's session, we're going to talk about the data science platform of the future, like I just mentioned. And VMware did a lot of really cool acquisitions and developments in the past, let's say 2 years. All focused around, bringing developers into today's platform, and technologies like Tanzu and everything around the actual Pivotal acquisition made stuff like that possible. So in today's session, I also want to basically talk about what the differences are between data scientists and developers, because they're sometimes treated the same way on a platform, but they have a lot of differences. And so let's talk about data scientists and developers first. So a data scientist is not a developer, right? So a developer builds and creates code, software and applications, and they write, debug, and execute source code for a living. So that's basically what they do, right? All day. A developer pushes code for a living, and they use CI/CD pipelines and solutions like Kubernetes to bring code to production. Now, they don't care about the infrastructure. So they just want to push code. And if all goes well, they create and push their code to make it highly available, resilient, and they don't care about things like high availability, because the underlying platform on which they push the code should be highly available by itself. So they should be able to create real cloud native applications. Now, a data scientist is a bit different. So they collect, analyze, and interpret large volumes of data and develop statistical models that analyze data and detect patterns. And so they analyze the data for a living, and they do that through building code and test the code in real time to build, test, and validate models. Now, they use AI frameworks and do care a lot about the infrastructure, and that's mainly due to the fact that a data scientist always could use an indefinite amount of resources. There isn't a platform that offers enough resources for a data scientist to get the most out of the things that they're doing, especially when talking about big chunks of data. And honestly, they don't know really. On average, they don't really know what things like Kubernetes are, because they normally don't work with stuff like that. Now, I mentioned artificial intelligence, and let's dive a little bit more in AI first. So maybe you recognize this fella. This is Alan Turing, and Alan Turing was famous for a couple of things. First of all, he was part of the team that broke the Enigma code, and that can be seen as one of the breakthroughs, or maybe the breakthrough in the Second World War. It ended Second World War, and he also created the Turing Test, and that basically is a test that says that if a computing device is able to mimic a human in terms of having a conversation, and the other side doesn't really detect that it's a computing device or an algorithm or code or something else, it passes the so-called Turing test. Now, if you want to know more about Alan Turing, there's a really cool movie on Netflix. I think it's on Netflix. It's called The Imitation Game, and it basically describes the whole story of him with the team breaking the Enigma code. So I really recommend watching that. Now, there are two main forms of AI. The first being general AI. And when thinking about general AI, most nerds like myself probably think about Jarvis from the Iron Man movies. And Jarvis is a form of AI that doesn't really have a specific purpose or goal. It can basically do anything, right? And it's kind of a bit like the same from Skynet from the Terminator movies. It doesn't have a specific goal or purpose. It does stuff. And like I mentioned, we refer to that type of AI as general AI. And although, something like that seems possible in the near future, it really isn't, because we simply don't have enough computational power to pull it off. Now, the second form of AI is narrow AI, and narrow AI focuses on a specific goal. Things like object recognition, like Jin Yang does in his seafood application. The app is able to detect if an object is a hot dog or not a hot dog. Or the algorithm that was created for Google's AlphaGo platform is the same thing. It was created for a specific goal, and the goal in that case was to beat the world's best Go player. Go can be considered as the world's most complex board game. Now, if you want to know more about Jin Yang, I highly recommend checking out HBO's Silicon Valley TV show. The show ended, but it's still really, really awesome, and probably one of my favorite shows. AlphaGo, Google's AlphaGo, there's a Netflix documentary on it, and that's really, really awesome if you want to know more about AI and how they were able to create that model and see what the result is. Because I'm not going to spoil anything, but it's really it was really cool to see. Now, AI has a couple of subsets. The first being machine learning. And to explain how machine learning works or what it does, I want to show an example. Now, you might have seen a message like this in your mailbox. Maybe it hasn't popped up in a while because, well, currently everything that is being sent from Nigeria ends up in your spam filter. But imagine you living 20 years ago, right? Email was becoming mainstream or almost mainstream communication type. And spam filters, well, imagine you being the first person in the world creating a spam filter, right? The thing is how to write code, because you might have been a developer, have been using if then else statements. Now, imagine you designing that spam filter. You have a condition, which is called a sender in this case. So the sender is, if the sender is Nigerian Prince and the SMTP host is mail.nigerianroyalemail.com, you block the message. So in this case, if everyone who sends an email with these conditions is being blocked, right? So no message from the Nigerian Prince in this case comes through. Now, the people from the Nigerian royal family might figure this out, and they create a second condition, right? And now you as a developer need to create a second condition as well to make sure that you can block that message. And another one, and another one, and another one. And suddenly you end up with a shit ton of conditions, maybe over 200, 300, and your code isn't really that efficient anymore. Now, this is where machine learning comes into play. Because what machine learning does is use structured data. An email is a form of structured data. So every email as a component or as a data source has the same type of object in email. So it has a recipient, it has a sender, it has a body, it has an like a topic or subject, and all of those emails that come in are being compared. Now, you as a consumer of a spam filter have the possibility to mark an email as spam. What happens is that machine learning algorithm is being fed by all of those emails, and all the marked emails are being marked as an anomaly. And the spam filter is able to detect, or the machine learning algorithm is able to detect what the similarities between anomalies are. And thus, it's able to predict next time if an email is a spam or not. And the more you train it, the more anomalies it's able to detect, the better the spam filter eventually will become. Now, this is a perfect example of machine learning. The next subset of artificial intelligence is deep learning, which is a subset of machine learning. And deep learning works a little bit different. Deep learning, works based on a neural network. And a neural network can be basically compared by the way a network of neurons works in your brain as well. So you have different neurons with connections between those neurons, and based on how the connections are being trained, one connection could have a higher weight or a higher value than the other ones. Now, you basically take an input and an output. And the input in this case could be a picture of a cat, and the output of the neural network is a 96% cat in this case. Now, in order to train the network, you need to do a couple of things. You need to have data, in this case, unstructured data. So a deep learning algorithm works with unstructured data. You label the data, in this case, dogs, cats, and Ewoks. You feed all of that data into the neural network. Connections between those neurons are being created and certain weights. And the output, in this case, of the neural network is a percentage of dog, cat, and Ewok. Now, in order to validate the neural network, you basically feed another picture in it, in this case, something that might look like an Ewok, a dog, or a cat, and the neural network is able to predict, in this case, it's 45% dog, 3% cat, and 52% Ewok. Now, the session has a subtitle called the Nerdfest demo, or the demo Nerdfest, and it's time for the first demo. So in the first demo, I'm actually going to show a deep learning application. I'm going to train a neural network, and I'm actually going to validate the neural network as well. Now, I'm going to stop the presentation, so bear with me for a couple of seconds. I have a camera here that I'm going to arrange right. Okay. And now I've got a couple of objects that I'll put in front of an application. Now, if all goes well, you should be able to see my screen here. And you see the application. The application is called the Femog Deep Learning Training Demo. And what I'm going to do here, it's based on a Jupyter Notebook application, is going to run all of those cells. Now, those cells do different things, and I'm going to guide you a little bit through it. The first is going to connect a camera. Next, we're going to import some modules and define different categories and different labels for the data. Then I'm going to create some widgets. Next, I'm going to import Torch and Torch Vision, which are modules specifically for deep learning. And I'm actually going to connect a Torch device based on CUDA, which means I'm going to use a physical GPU. Now, hoping that everything is already loaded. If I put my hand in front of the camera, yes, it works. Now, what I'll do first is create a couple of pictures of some objects. So I have the bro code here. Let me move the camera a little bit. So I have the bro code here, a little bit. So right, yes. And I'll take a couple of pictures of the bro code. I'm gonna do the same thing with another object, an ITQ avatar, which I have here as well. Put it in front of the camera, take a couple of pictures. Finally have a third object, which is called a power ball to train your wrist. Take a couple of pictures. And next, I'm gonna launch the training phase, which I'll do a single epoch, a single iteration, and run it. Now, what will happen now is that all of the pictures are being run through the neural network, which you can see here, the progress, and the whole idea is to have a really low loss and a really high accuracy. The higher the accuracy, the better the prediction of the model will be. Now, a single epoch isn't really enough to have a really cool neural network, but we'll go through that a little bit later. What I'm going to do first is run a couple objects in front of the camera and try to let the neural network detect what we're doing here. Now, as you can see, in this case, the single iteration wasn't enough. Well, it does detect it's the bro code, and it might detect the IDQ avatar as well, but in certain camera angles. So it isn't trained enough. We'll fix that later on in a demo. I only do live demos, so sometimes stuff like this happens. Now, what I'll do next is shut down the app and go back to the slides. Right, so you should be able to see the slides again. Next, we're going to talk about Bitfusion. So last year I was telling or presenting a lot about VDI Bit Compute per Night, and I highlighted a technology back then already called Bitfusion. Now, VMware acquired them almost 2 years ago, or 1.5 years ago, and I think that was one of the seriously, like the most awesome acquisitions ever, because Bitfusion lets you virtualize a GPU, specifically from a compute purpose only, so no graphics virtualization, and it remotes so-called CUDA instructions over the network. So that's really awesome. And I'm going to talk a bit more about Bitfusion in a bit. Now, the application I just showed is basically a deep learning application running inside a container. So what you can see here is that in my lab, I have hosts without GPUs. Those are running Ubuntu virtual machines, and the Ubuntu virtual machines are running the deep learning container, so the deep learning applications inside Docker files. Now, I have hosts with GPUs, and those have two RTX 6000 GPUs, so those are Quadro-capable GPUs and data center certified. And I have a Bitfusion appliance virtual machine that has those GPUs passed through. Now, the Bitfusion appliance has CUDA installed and the NVIDIA driver. And if we take a look at one of those running applications, it's based on Docker, like I mentioned. It has Python installed, so my application is Python-based. It has TensorFlow as a deep learning module. It has CUDA installed inside the application, but because, of course, CUDA is the way computational instructions are being sent to a GPU. And it has the Bitfusion client installed, or the Bitfusion agent. Now, if the application is sending out CUDA instructions, the Bitfusion agent intercepts them and sends them over to the network to the Bitfusion appliance. Now, stuff is being calculated, the result is being presented back to the Bitfusion agent, and the Bitfusion agent in its turn presents the result back to the Python app. This is really cool, but let's show it in a demo. So in the next demo, I'm going to show the same deep learning application. I'm going to run a longer training job, and I'm going to show the statistics in the Bitfusion server. So we're going to end the slides again, put the app in front of everything, and I'm going to do the same thing like before. So run a couple of training epochs, but in this case, I'm going to start 5 of them. And they're going to train based on the same data. Now, what will hopefully happen is that the number of epochs will, or the accuracy will be a bit better. In the meantime, what we'll do is go to the vCenter appliance, go to the Bitfusion option, And what you can see here is that we have, hopefully, yes, we have a Femog demo application running. It allocated a GPU. And what we can see in the server, if we take a look at the last 5 minutes, it's being allocated. So the application uses the GPU. It uses some GPU memory, a little bit of GPU computational resources, but it's a tiny application, so you won't see it spiking. It sends and receives some stuff over the network, and if we take a look at the GPU details, we can see that 1.3 gigs of frame buffer is being used, and just 4% of GPU computational resources. My application is really tiny, and every picture I take is just 640 by 480. So hence the small size and the low amount of resources that are being consumed. Now, if I refresh it a bit, it will, well, you can see it's still 3-4%. Now, yeah, the network, you can see it's pushing 14.4 megs a second over the network or receiving, and it's sending almost nothing, just the result back. Now you can see here also that I have a couple of clients, and what's really cool is that if we go back to the cluster, you can see I have a Bitfusion server and I have a couple of VMs. Now the actual VM that the deep learning app is running on is called DL03. So that's an Ubuntu VM. But as you can see here, it doesn't have any GPU attached. So the actual application has a GPU attached or GPU allocated, but the VM doesn't really know anything about a GPU. So I think this perfectly shows the power of Bitfusion. So from an application side of things, I need to talk to a GPU, but the VM in its turn doesn't know anything about the GPU, and hence doesn't really need to have any GPU related configuration either. Now, if we go back to the app, we can see that the accuracy was 0.90 and now is 0.96. So it's a lot higher. And if all goes well, and I put the Powerball in front of it, yes, it perfectly detects it's a Powerball, right? And that wasn't the case before. Now the avatar being detected, and hopefully the same or the bro code, yeah. And the loss is a bit lower as well. So this is, I think it perfectly shows that more training is necessary to actually get the best results possible. And it also, this demo also shows that where the power of Bitfusion lies. Right, you don't need to allocate a vGPU profile, for instance, to a VM, and specifically to a container. That's even not possible. So combining, in this case, a Jupyter-based application with a Bitfusion agent and perfectly assign a GPU over the network and release the GPU as soon as the application is finished. Makes it a lot more scalable to utilize those GPUs from a data science perspective. Now let's go back to the slides again. Almost. I need to do something just prior to the next demo. Let me check if all is going well. Yes, okay, cool. Let's go back to the slides. Right, so I started the deep learning app, ran a long training job, and showed its statistics in the Bitfusion server, right? Now next, because I already mentioned data science, already mentioned deep learning applications, containers, stuff like that, but vSphere has all sorts of really cool new features, and the whole introduction of Tanzu brought a lot of possibilities to the data science game. So how would you approach something like that? Now I have a small architecture diagram of what my application looks like. So I have a Docker container, container running with the Jupyter lab-based application. And in my next demo, I'm going to show that I have deployed the TKG appliance or the TKG demo appliance even, which can be downloaded for free from the Flink site. Awesome. A lot of credits go out to William Lamb for creating that, because in matter of just a couple of minutes, you have, or let's say 30 minutes, you have a full TKG instance running in a data center. So it's really awesome. So I'm going to show Harbor, which is included in TKG and is basically your container repo. I'm going to show the link with Tanzu. I have Bitfusion running, and I'll show the connection to the NVIDIA server. Now, demo time. I'm going to pull a deep learning app from Harbor. I'm going to show the pod in Octant, which is a HTML5 based view of what's happening in Kubernetes. And I'm going to run through the Docker logging to actually show what's happening. Now, let's first put the. So this is Octant, and what I'll do first before we go into Octant is take my TKG management interface, management console in front of, so you can see what I'm actually doing here. So I'm running a kubectl command to run a demo application and pull it from the rainpool.io registry, which basically is the local Harbor registry. What I'll do to show that even a little bit more is first go to Harbor. Now you can see here in Harbor, this is where my projects reside. There's a project name called DL Demo. So that's my demo application. Now, when I now open up Octant again, put the command line in front of it, and now run my app, the pull command of my app, you can see that it's already being pulled. So that's really cool. Now, move away the command line. Now next, you can actually see that if I open up the app, a couple of things are being created. First of all, it's being exposed over port 80808080. It's being exposed on this IP address, and it has a Jupyter Notebook application enabled. Now, when I open up the log files, you can see that the Jupyter Notebook service is being started, but this is it, right? Now the app, which is this one, and I'll refresh the screen a bit. A kernel now is starting with Bitfusion. So nothing happened from the application side of things, but now I'm restarting the app. And what will happen in the meantime is if I open up Octant and show the log files, that you can see that the application is requesting a GPU with this amount of frame buffer. It logged a GPU, and I'm able to utilize it fully. Now, if I now run all of the cells, run all cells, probably won't be able to see anything more from a log perspective, no. But this is the actual application that is running from a Kubernetes side of things. So this is fully running in TKG, while the TKG nodes in the service don't have any idea of the concept of a GPU. So again, the GPU connectivity fully exists inside the container and not outside the container, which makes it really powerful. Now, if all goes well, yes, my hand is here again. You can see that the application is perfectly running. Right. Now, go back to the slides. And for the next and final section of the presentation, I want to talk about Project Stig. I've been working on a personal project for over 6 months, and it involved a lot of. I wanted to learn more about deep learning and how it works and how you can combine it with VMware technologies. And one of the things I did was find a use case. In my case, autonomous driving. So I built a project called Super Awesomely Trained Intelligent Guiding System, Project STIG. Now, the first thing with what I thought of when thinking about artificial intelligence or deep learning or neural networks is autonomous driving. Now, in this clip, and it doesn't have sound, but it should be running. Yes, you can see that an NVIDIA-powered car is completely loaded with all sorts of sensors, over hundreds of sensors. And multiple neural networks are constantly being fed by data that's being read from the sensors. Sensors like, well, you can see here road signs. You can see other cars that are being detected, the speed that I'm driving, stuff on the road, like the asphalt, detection of where to, based on sat-nav and geolocation, where to take an exit, stuff like that. It's all being collected and fed into the neural network. And the neural network is being utilized in an application, and the application is making decisions. Go left, go right, hit the gas, take a break, stuff like that. So that's all part of the application residing in the car. Now, for my project, I wanted to do it a little bit differently because I don't have the possibility of driving an autonomous car for 10,000s of hours and millions of miles. So I did it a bit differently. But I still, did a lot of driving, and I spent over 6 weeks of driving, a couple of hours a day, and generated a lot of data. Now, that data was being used to train my model. My model and training of the application has been done through a comparable app like the Jupyter Notebook app I shown, but without the Jupyter Notebook interface. So basically a Python script that did a lot. But because of the large amount of data and the complexity of the training app, I needed not one, but 2 GPUs. And the app itself wasn't really capable of running that on a multi-GPU instance. So what I did instead, oh, crap. Let's go back here. What I did instead is put Bitfusion between the app and the GPUs. So it was capable of running it distributedly. Now, results after a couple of weeks of training, results being presented back and fed into a neural network. But like I mentioned, a neural network itself isn't, it's capable of predicting something, but it's not, it's just part of an application. And the application in my case is called, or in general, is called an inferencing app. So you have visual data, you feed that into the neural network, and based on the output of the neural network, you execute controls. Now, the controls are being sent, in my case, to a car, and will define controls within the car. So go left, go right, speed, object, avoid object, stuff like that. Now, let's go to the final demo of today. I'm going to show a deep learning application. I'm going to start a neural network, and I'm going to run a simulator. Now, this is a pre-recorded demo, but that should not take away the fun. So what you can see here is a Windows desktop. So it's a desktop hosted on Horizon. And in the box at the right, you can already see that the neural network is being connected. So the neural network is running on my backend. It's also inside a deep learning Docker container. And if all goes well in a bit, well, you can see that it perfectly connected a GPU over the network. If all goes well, the application will be started in a bit. The actual simulator. Almost. And the thing is that the neural network is running on the network. It's being pre-trained from a deep learning perspective. Now you can see here the actual simulator, and if I now unpause the emulator, nothing is happening, right? Now we're going to start the neural network, and at the right, you can see in the rectangle a couple of boxes. The above rectangle being the actual road that's being detected. Now the rectangles below it, or the rectangles below it, are the different layers within the neural network. So you can see 5 different layers, and the rectangle below that presents the controls. So the output of the controls: go left, go right, steer, throttle, brake. Now, in the specific type of neural network that I've used here is called a recurrence neural network, which basically means it mimics my driving skills. Now, as you can see, Mario is not that good at this point in time, and that's basically because I wanted to do something differently. I wanted to, of hours and hours of driving. Sometimes I did my best, sometimes I did not do my best, and based on all of that gathered data, Mario is doing basically mimicking my average driving skills. Sometimes it's speeding, sometimes it's driving the wrong way, but at the end, it's doing its best. Now, I think this is really perfectly shows the power of deep learning in a non-conventional use case, but a really fun use case to learn how to code, how to build Python applications, etc. Now, for the sake of time, let's go back to the slides and end with a couple of questions. So if you have any questions, I'll be able to answer them through either a Q&A or through Twitter. So you can find me at @vhoyan, and I'll be answering any questions you might have regarding this presentation or anything in general. For now, thanks so much for watching, and enjoy the rest of your day.